Let's start with a simple question to ChatGPT and see what it will say. The first step to making such a system is to have good data. Also, it recommended this website where we can have the data that we need. You will find the link to the website in the description. The dataset is really rich and has much data. As you see, there are various types of data in this dataset, and this variety will be helpful for the learning process to achieve a good accuracy. The good thing about this dataset is that it is pre-processed, cleaned, engineered, and labeled with different types of targets. There is a free version of the dataset, but it only contains historical data for 1 month, which is not enough. But don't worry, I will provide the full version for free if you just contact us on the chat dialog and tell me that you are coming from this channel. Now let's go back to ChatGPT and upload the dataset to see what is inside. The dataset will save your time and effort on data processing and data cleaning. I have also asked it to perform a basic exploratory data analysis, EDA. Now we are ready to start building the great model. You just need to download the dataset, make your coffee, and be ready for the next step. Before we start, don't forget to support the channel with a nice comment, like, and subscribe. Open the Google Colab where we will do all the work. https://colab.research.google.com. Name your project. I prefer to organize my project section by section. I usually start by the requirements and library imports. Run this part of the code, and if you get a green tick, you are good to go. Most machine learning libraries are available in Colab, however sometimes you need to install some unavailable libraries using pip. In this section, we will load the dataset into your script, perform some checks, and perform basic data analysis. Make sure you upload the dataset file to the working path. Here we list all of the columns in the dataset with their index so we can select the features and targets that we want. Check if there is any missing data. Good, the data is clean and complete as this dataset has been already cleaned and processed. You can also plot the time series data of the daily closing price if you want to see what it looks like. It is recommended in machine learning to understand the correlation among the dataset features where the highly correlated features could cause overfitting issues and affect the learning performance. However, in this case, we will not work on feature engineering and will use all the dataset features. Before we begin constructing any complex models, it's beneficial to conduct some benchmarking using simpler models. This will help us determine whether complex models are necessary and also aid in understanding the computing resources required for our project. We always start with the most simple regression model. Test the predictions with all the next X day price targets. Select the features that you want to use in the training process as features. It looks good in short-term predictions, but not in long-range predictions. In this project, we focus on the long-term predictions. Let's try one of the most powerful machine learning models and see how it will perform with our data. XGBoost model did a great job with our dataset and the fitting line looks perfect. Now we will make the LSTM deep learning model designed to deal with the time series data like what we have. Creating an early stopping function will help to improve the learning process performance and save both the time and effort of your machine. It is used to stop the learning process if there are no more improvements, because sometimes the learning improvements stop after a certain number of epochs. In the case of time series data, you should pass a group of data points instead of giving one day of data to predict the next month's price. It is the same idea of passing an image of the market chart so the machine can have a better look at window of time range like 60 days of data at once. Unlike the other machine learning models, in deep learning models like LSTM, it is very important to scale the feature data before it is passed to the neural network to avoid underfitting issues. Here we start designing the model architectures and determine how many layers, types of layers, and how many nodes we will use for each layer. In the first experiment, we will start with a simple network architecture and will make it complex step by step. Make sure you upload the dataset and run the important code blocks that will be used by the LSTM block, as I am doing right now. It might take a long time depending on the computing power that you have, but if you don't have GPUs, you can use Colab with Pro subscription. Now we can get some performance evaluation to know if the learning process works fine or not. Here I started the second experiment, where I made the model architecture more complex with multiple layers and more nodes, and also changed the activation function to ReLU. The accuracy is improved as shown on the list of metrics, and it was faster to converge. In the third experiment, I increased the number of layers with more number of nodes. In this experiment, I just tried to change the learning rate and see if that would make it better. Again, underfitting issue and bad performance. Change the number of nodes in each layer and the learning rate. I know that you are asking yourself now why I chose these values. Actually, those are not chosen randomly, and in the next video I will explain how we can tune your model for better performance. We got great results, and it is a bit better than the XGBoost model. However, in the next video, we will make it even better. Look how the learning curve is beautiful.